The P wave represented atrial depolarization, the moment electricity spreads through the atria, causing them to contract. The electricity then reaches the AV node, and there it will stop deliberately. Not because something went wrong, but because that's exactly what's supposed to happen. And this pause happens 100,000 times a day. The AV node is a gatekeeper. Its job is to delay. This delay is on purpose, because the ventricles need time to fill before they can fire. If the signal passed through instantly, the ventricles would contract too early before they have the chance to fill. The AV node holds the current just long enough to prevent that from happening. This pause is referred to as the PR segment, which is the flat line between the end of the P wave and the start of the QRS complex. That's the true AV node delay, isolated. But here's the problem. Identifying the end of the P wave is harder than it sounds. The P wave tapers off gradually, and different leads show it ending at slightly different points. So, clinically, we measure the PR interval instead, which is the point from the start of the P wave to the start of the QRS complex. Both of these points are easy to locate, and two different clinicians will land on the same number. Changes in the PR interval reliably reflect changes in AV nodal conduction. So we've just mentioned that the PR interval starts at the beginning of the P wave and ends at the beginning of the QRS complex. This part includes the atrial depolarization, represented by the P wave, and the AV nodal delay and conduction through the His bundle, represented by the PR segment. A common misconception is that the PR interval measures the atrial conduction time alone. It doesn't. Atrial conduction is one component of the interval. The largest contributor to the PR interval is the AV nodal delay. It's easier to measure the PR interval in the lead where the P wave is clearest. Usually, that's lead 2. The normal PR interval is about 120 to 200 milliseconds. That's equivalent to 3 to 5 small squares horizontally on the ECG paper. And if you remember with me, one small square horizontally was equal to 0.04 seconds or 40 milliseconds. So less than 3 squares means that the AV nodal delay is too short, and more than 5 small squares means that the AV nodal delay is too long. The PR interval should be consistent beat to beat. The same PR interval tells you that the AV node is conducting steadily. The PR interval represents the electrical footprint of a deliberate pause in the AV node. This pause exists so that ventricles can fill before they contract. A short PR interval means the electricity crossed too fast, and a long PR interval means the electricity is crossing slower. A consistent PR interval is the best. It means the system is working properly. After the pause is over, the electricity passes through into the bundle of His and spreads into the ventricles. That's the QRS complex. That's all. Thank you and see you in the next lecture.